Alright, good afternoon. Now let's carry on with our AC power. And if you recall, the complex power is equal to VI. Now there is this one special formula that many of you actually don't quite understand what it is. Basically it says that complex power is equal to voltage multiplied by the current conjugate. Now the whole purpose of this formula is to make sure that your power triangle points up and points down accordingly. Okay, let's recall with an example. Let's put this formula aside first. Now, if I have an AC circuit with a resistance and an impedance, right? My voltage is 0 volts, and my resistance is 3 ohm, my reactance is J4 ohm, right? And if I'm going to find my current, right? So my voltage is 0 volts, and my impedance is equal to 3 plus J4 ohms, right? So that is equal to 553.13 ohms. Yes or no? That's my impedance. And when I find my current, I'll say voltage divided by my impedance. Voltage divided by my impedance. Okay? So I would have 0 divided by 553.13. So that is equal to 2 minus 53.13 ampere. Right? So if I were to see my complex power, and if I straight away using V times I, so that will be giving my V is 0 and my I is equal to 2 minus 53.13. So that is equal to 20 minus 53.13 volt ampere. Right? That's my VI. Now, if I were to draw, based on this, if I were to draw my power triangle, the power triangle will be pointing down. Yes or no? And you know that it's wrong. Why is it wrong? Because from this circuit, this is an inductive circuit. This is an inductive circuit, so your power triangle should be pointing up, right? It is an inductive circuit. And you know that for inductive circuit, the power triangle should be pointing up. P plus JQ and then S. Correct? But unfortunately, if you were to straight away doing your mathematics S equal to V times I, your power triangle is pointing down, which is different from the one that we know that it should be pointing up. And that's why this formula, complex power is equal to V multiply I conjugate, would rectify this problem for you. So in other words, if you were to say now we would do my V, that will be 0 My I conjugate basically means that if I is equal to 2 minus 53.13, you make the angle into positive angle. Right? So that gives you 53.13 So now the angle is positive, so the power triangle now is pointing up, which is the correct one. Yeah, which is the correct one. So that is what this S is equal to V times I conjugate is all about. It's about making your power triangle point up and point down accordingly. If you find it too difficult to understand, what you can do is that do your mathematics accordingly. Right? Find your impedance and find the current, and then make the complex power the normal way of mathematics. So your power triangle is pointing down, right? So now you say, okay, you can add on this instruction here. Say, since the circuit is inductive, therefore the complex power is equal to 2053.13 VA. Right? If you do your mathematics like that, it's still acceptable. But if you do not want, then you can write away using this conjugate method. Right? If I conjugate means that if I is equal to 20 minus 53.13, the I conjugate is to make the angle positive. Positive. Right? So straight away putting it, your power triangle will point up accordingly. Right? Or point down accordingly. Does it make sense? Right, let's try one more example. This time we try with a capacitive impedance. This is a capacitance, so let's say it's this minus J4 ohm. So my mathematics will be still the same. V is equal to tan 0 degree, but my impedance now is minus. So if using a calculator, this is minus. Right? So if I do my mathematics again, it's minus 50, so here's positive 53. And if I do my mathematics V times I, it will be like this. Right? And since the circuit is now capacitive, your complex power is minus 53. Because positive 53 means the triangle is pointing up, right? And because it's a capacitive, it shouldn't be pointing up. You know that it's wrong. Right? It should be pointing down. So in order to make it correct, you put this English statement here and say that it's minus 53.13. Right? Or if you prefer, a better way is to use this conjugate method. Alright? The power triangle that I recognize is actually a pointing down power triangle because it's a capacitive circuit. Right? So I say I conjugate. Now my I is now positive 53. So I conjugate will become minus 53.13. So you put down minus 53.13 and your mathematics will become a complex number pointing down. Alright? So that becomes the power triangle that is pointing down, and that is the correct answer. So B minus J, Q, and S. How do I know it's pointing down? Because the angle is negative 53.13. Got it? So that is called a complex power is called the V times I conjugate. Okay? It's a very powerful formula to make sure that your power triangle points up and point down accordingly. Alright, of course now it's capacitive, I didn't change that one just now. Okay, yeah, that's all. Thank you.